Hello everyone. Welcome to the mini lecture on electromechanical control technology. Today, we will learn about the common control methods and principles of electromechanical control technology. We will begin with the following two topics. Electromechanical control refers to a method of controlling mechanical equipment using electronic and computer technologies. It involves the integration of hardware, such as sensors, actuators, and controllers, and software, such as control algorithms and programming logic. Electromechanical control systems are widely used in various fields, such as industrial automation, automotive, aerospace, and household appliances. Now let's take a look at the learning objectives for this lesson. 1. Understand the basic concepts and application areas of electromechanical control technology. 2. Master the common control methods and principles in electromechanical control systems. 3. Recognize the important role of electromechanical control technology in modern industry and social development. Please think about and answer the following questions. Can you list a few application examples of electromechanical control technology? One. Depending on different application scenarios, electromechanical control can be divided into multiple types, each utilizing distinct control methods and technical approaches. 1. Open-loop control. An open-loop system is also known as a feedback-free system. An open-loop system is a system where the input affects the output without being affected by the output. Since there is no closed feedback loop formed inside, it is like a disconnected loop, hence it is called an open-loop control system. Since the output does not affect the input, the open-loop system cannot respond to output deviations and disturbances, but only makes a specified response to the set value. For example, a clock is an open-loop system because it does not observe whether it is accurate or not, nor does it adjust itself. For instance, the control system of a stepper motor is a typical open-loop control system. The numerical control device sends feed pulses to the power amplifier, which amplifies the pulse signal and then drives the stepper motor. The motor moves the workbench left and right, fast and slow through the transmission mechanism. 2. Half-closed loop control system. The half-closed loop control system includes an indirect feedback mechanism. In this system, the servo mechanism of an open-loop control system is equipped with an angular displacement detection device. By detecting the rotation angle of the ball screw in the servo mechanism, it indirectly measures the displacement of the moving part and then feeds this back to the comparator of the numerical control device. This system compares the detected value with the original commanded displacement value, using the difference for control to make the moving part adjust its displacement until the difference is eliminated. For example, a servo motor driving a lead screw table to move left and right is a typical half-closed loop control system. This system works by sending signals from the numerical control system to the servo driver, which amplifies the power drive and sends the drive signal to the servo motor. The servo motor drives the movement through a transmission mechanism to achieve left-right and speed control. The end encoder of the servo motor feeds back motor speed and rotational angle displacement signals, which are also indirect signals of the table's speed and displacement, to the servo system. Such a control system is briefly known as a half-closed loop control system. 3. Closed loop control. The closed loop control system includes a direct feedback mechanism. It takes a portion or all of the output of the control system and returns it to the input end of the system through certain methods and devices. Then, it compares the feedback information with the original input information and applies the result to control the system, preventing deviation from the predetermined target. The closed-loop control system utilizes negative feedback. That is, it is an automatic control system that forms a closed loop through a forward signal path and a feedback path, also known as a feedback control system. For example, after a numerical control device issues command pulses, the servo driver amplifies the power drive and sends the drive signal to the servo motor. The servo motor drives the movement through a transmission mechanism to achieve left-right and speed control. A linear scale ruler installed on the work table measures the position and speed of the work movement and feeds back these signals to the servo system. Such a control system is briefly known as a closed-loop control system. 4. Proportional integral derivative control, PID control. PID control is a commonly used closed-loop control strategy that adjusts the control variable by calculating the proportional, integral, and derivative terms of the error. This achieves rapid response, eliminates steady-state errors, and suppresses overshoot. 5. Digital control. Digital control systems use digital devices such as microprocessors or application-specific integrated circuits, ASICs, to perform control logic operations. These systems typically have strong computational capabilities and flexibility, allowing them to implement complex control algorithms. 6. Fuzzy control. Fuzzy control systems utilize fuzzy logic theory to handle uncertainty and vague information, making them suitable for nonlinear systems or complex systems that are difficult to model. 7. Adaptive control. Adaptive control systems can automatically adjust control parameters according to changes in the external environment to achieve optimal control effect under different conditions. 8. Intelligent control. Intelligent control systems integrate artificial intelligence technologies such as neural networks, genetic algorithms, expert systems, etc., providing the control system with certain learning and reasoning capabilities to better handle complex and varied control tasks. 9. Field bus control. Field bus control systems connect various field devices through communication networks, achieving data sharing and distributed control. This enhances the integration and maintainability of the system. In this lesson, we have learned about the classification and control principles of electromechanical control systems. In fact, electromechanical control systems play an extremely important role in modern industrial and social development. They are irreplaceable in improving production efficiency, ensuring product quality, reducing costs, and achieving intelligence. They have driven the modernization process of industrial production and are the key driving force for industrial modernization. As future builders, mastering electromechanical control technology is crucial for you, so you must study hard. Lastly, please think about this lesson and complete the following exercises to consolidate today's knowledge points and deepen your understanding. That concludes our lesson for today. See you in the next lesson.